So we talked a little bit about ratios. Now we're going to summarize it with some notes. A ratio is the comparison of two numbers, technically. I, however, have used the ratio format when I have three or more numbers to compare. You're going to have a word problem that has three things that are being compared, three ingredients to something. I've used it because I've compared the part, and the total, and I wanted to sort of keep them all linked together. So even though technically the ratio compares two numbers, sometimes we do a little bit more flexibility and use the same format to look at more than just two numbers. So when we're looking at ratios, even if we're looking at this simple diagram here, where all we have is 5 circles, 2 of them are filled in and 3 of them are not. That simple diagram gets us 6 different ratios. And those 6 different ratios can be written in a multitude of different ways. So within our notes, we'll come up with the 6 ratios and we'll write them a few different ways so that you can have an idea of what you'll be seeing. So a ratio could be comparing a part to a whole. So in this scenario here, the filled circles compared to the total, you might say that there were 2 to 5. So the part to whole ratio is oftentimes written as a fraction, because 2 out of 5. But we could still see the fraction format even if it wasn't part to whole. We could see the unfilled compared to the total as 3 for each 5, or some phrasing of that sort. 3 for every 5, 3 per 5. All these different phrases that could say I'm having 3 of these each time I have 5 of those. You also might see ratios, and oftentimes you see ratios that compare part to part. So about the bird feeder food, it's 4 parts water for every 1 part sugar. So the filled to unfilled in this diagram up here, there are 2 filled in and there are 3 not filled in. A very common way to see ratios is with that colon, that punctuation mark, the colon. So the filled to unfilled is 2 to 3. Or we could have the same parts being compared but in the other order, and that's considered a different ratio. So the unfilled compared to the fill, I might write as 3 to 2. And I can write it in that fraction format even though it doesn't actually mean a fraction. But what I don't want to do is change this to 1 1/2. I need to be able to see the first number compared to the second number. So always as a numerator as the first number that's involved, and the denominator is the second number. And then we also could be comparing the whole amount of the collection compared to a part of the collection. So the total compared to the unfulfilled, we might say it's a 5 to 3 ratio. Or the total amount of circles compared to the filled circles, you might use it as the 5 to 2 ratio. So oftentimes you see it with the colon, but words are sometimes used for ratios and the fraction format. So any of the above notation is appropriate. And then even if a ratio is written as a fraction, never turn it into a mixed number or whole number. So if you're going to have trouble with that, you might want to avoid the fraction format. Some people love putting the ratios into the fraction format because for them it reminds them to simplify if they can. Simplify the ratio, just like you can simplify fractions. But if you are just such a good doobie that you never want to leave an improper fraction answer, that you might accidentally try to turn it into a mixed number or whole number, you might want to avoid the fraction format. But anywho, real life scenario. Who wants to read the first one? Raise your hand if you're feeling like you would like to read for us this scenario. Real life. I was watching a Red Sox game while I was doing some math geek work. Yes, ma'am.
At a Red Sox game, the scoreboard showed the Toronto Blue Jays had 6 hits and the Boston Red Sox had 9 hits. Jerry Remy said, "We are out hitting Toronto 3-2. Was he lying? Explain."
So my math geek radar went off. What? Did he just say the ratio? We're out hitting 3-2? So then I looked at the scoreboard and I actually jotted it down and whatever I had near me. So this was a real life scenario where we said we're out hitting Toronto 3-2. But the scoreboard didn't say 3 and 2. It said 6 and 9. So who can explain what's going on with Jerry Remy? Was he lying? Why would he say we're out hitting them 3-2? Raise your hand if you think you can explain what's going on in this scenario. Sir?
He took the ratio 6-9 and simplified it.
Sort of. He didn't take the ratio 6-9.
Oh, yeah, 9-6.
9-6. He wanted to put Boston first to say we're out hitting them. So he took it and he switched the order, 9-6, and then he simplified it. Because you can divide a 3 out of 9 and you can divide a 3 out of 6. So I'm going to write an explanation here, and basically I just tried to make it so that it would get to the gist of it, but would fit on the lines. So no, he was not lying. He switched the order. And simplified. The ratio. By dividing each part. By 3. So in real life, oftentimes ratios do get simplified. But then you want to think about what the real numbers are. So they might give you one of the quantities in the real life. So you have to find out what your multiplier is to get back to the real life quantities. They give it to you in simplified terms often. You have to find your multiplier to get the real life quantity. Raise your hand if you can read for us the next scenario. Or if you'd like to read the next scenario for us. Not everyone likes to read aloud, so I pick from the volunteers. Except sometimes my sticks are not helping me. Yes, sir.
Did you know science requires a student to chaperone ratio of 15-2? How many chaperones would be needed for 90 students?
So it's a real life scenario, but typically they only say for every, say, 10 students you need 1 chaperone, or 8 students you need 1 chaperone. But in this scenario I made it so that it wasn't a unit rate initially. So that we could think about, well, what are you going to do with those numbers to figure out. So go ahead on your paper and do a little scratch work if you need to in the margin space to figure out how many chaperones would be needed if you have 90 students. And the ratio is supposed to be 15-2. So they give the ratio in simplified form. No matter what school district, it could be like, you know, a small school district that are only bringing 15 or 30 kids on the field trip. Or they could be a bigger school district where they're bringing 90 or 200 or what have you. So raise your hand when you think you found out how many chaperones would be needed. If you think you can help explain it to us, perhaps. Yes, sir. You need 12 chaperones. What's your logic there?
Because there's 6 sets of 15 or 90,
Mm-hmm.
and then it would be 2 chaperones for each set of 15.
Good. So essentially, we needed to find that multiplier. 90 divided by 15 means there's 6 groups, 6 field trip groups. And for each of those 6 field trip groups, we need 2 chaperones. So we multiply the 6 groups times the 2 chaperones for each group. So 12 chaperones are needed. Because you multiply each number by 6. Get an equivalent ratio. Just like we have equivalent fractions, we have equivalent ratios as well. This time we're looking for an equivalent ratio with 90 students. So by multiplying each part by 6, we end up with a ratio of 90 to 12. It's times 6 times 6. gonna give us the 90 to 12 that we're looking for. And then one more scenario before you go ahead and try some real life problems. So who thinks they want to read the last one about the dentist? It's a very common use of ratios, advertisements. Who feels like reading the one about the dentist? I wanna be a dentist. Yes, sir. Mm-hmm.
If 7 out of 10 dentists recommended a certain toothpaste, how many did not recommend the toothpaste when 250 dentists were surveyed?
So go ahead and think about your strategy to find out how many actual dentists do not recommend the toothpaste. If 250 dentists are surveyed, and 7 out of 10 do recommend the toothpaste. So again, if you need to do a couple computations, you can do that on the side there, on the margin space or what have you. Try to think about what your multiplier is and how you're going to find out the amount that do not recommend that Minty Fresh toothpaste that brightens your smile and helps prevent cavities. You know those ads. Raise your hand when you think you have it. This one is actually an example of the distributive property as well. Some people multiply the other, and then subtract. Other people subtract first, and then use their multiplier. Right now, a couple people we haven't heard from yet. We have 7 out of 10 recommend a certain toothpaste. There are actually 250 dentists surveyed. So I'm just going to have to call on you and walk you through it. So what's our multiplier? How many compared to the original simplified ratio? What's our multiplier to get to how many were actually surveyed compared to our simplified ratio? 25. So our multiplier is 25. So let's all make sure we understand our multiplier is 25 because we have 25 amount of the original simplified ratios amounts. Now here's where we can differ on where we go from here. We could multiply this by 25 as well, and then we could subtract. Or we could find out if 7 out of 10 dentists recommend it, we could find out how many out of 10 do not recommend it, and use our multiplier of 25. So do you want to multiply first, or do you want to multiply after subtracting?
Multiply after subtracting.
So after subtracting, if 7 out of 10 do recommend it, how many out of 10 do not recommend it?
3 out of 10.
Mm-hmm. Do not recommend it. So 3 out of 10 do not recommend it, and we have a multiplier of 25 to get 250 dentists. How many dentists do not recommend that particular toothpaste? We're going to multiply by 25. Well, there are 250 dentists altogether. 3 out of every 10 do not recommend it. So we're going to multiply the 3 by 25 to get how many?
75.
75 do not recommend it. There is the possibility that some people found the total amount that did recommend it, subtracted that from the 250 surveyed altogether to find that difference. But other people subtract first and find that 3 do not recommend it. So for here we have 75 dentists did not recommend the toothpaste. Oops, because 3 out of 10, bless you, or 3 out of every 10, do not recommend it. And there are 25 groups of 10. So multiply 3 by 25. So for some of it's just a matter of getting comfortable with the parts versus total. A lot of times I actually will write down part, I'll label it. The part of this, and this part of it that, and then the total. So I know what I'm given versus what I'm looking for in the question.